or in this lesson, we're going to be starting to talk about how to solve polynomials. There's many different methods to use. The first method is by factoring. Right, so we're going to be doing some factoring today in order to solve the polynomials. Right, so here's an example of a completed problem. So I just wanted to go ahead and look at this just so you can see what the end result is. So here's our original equation, right? You always set it equal to 0 first. So if you get something like what's over here, right, this does not equal 0, this equals 26, right? So this problem you'd have to first get it to equal 0. So that's something we're going to worry about later. Today I'm going to give you the ones that are all ready to go. So we've got it set equal to 0. Now we're going to factor. First thing you always do, always look for GCF first, right? So in this case, there's a GCF of 4x to the 4th. So you factor your GCF out, right? So remember, when you factor the GCF out, you're subtracting the exponent. 6 minus 4 is 2. 5 minus 4 is 1. 4 minus 4, no x is here. All right, so you factor your GCF out, and then you're going to look at what's left here. So now we're going to factor this. So you take your first term, you split it into 2. X and x get split. Then you look at the end, 6. What multiplies to make 6? 3 and 2. Then you get your signs correct. So this has to be a positive one to add. So what signs do I give 3 and 2 to make it add up to a positive 1? Right? After that, it's all factored. Once you're done factoring, what you do is you split it and set each piece equal to 0 and solve each piece for x. Right, so this first one, solve for x, you get 0. This one you get negative 3, and the last one you get positive 2. So the answer is 0, negative 3, and positive 2. Right. So now we're going to do some examples of our own. So we're going to start here. So first thing we always look for is GCF. Right? Always look for that first. So in this case, there's no number here, so I can't have a GCF of a number, but I can have an x, right? This is supposed to have an x on it. I apologize, I wrote the problem down wrong. Okay, so anyway, this has a GCF of x. So I'm going to factor out an x. So take away an x from each one. So I'm left with 2 here, 1 here, and no x's on the last one. All right, I took 1 away from everything. Right, now I'm going to factor this one. So x squared becomes x and x. Then we look at 27. Now 27 could be 1 times 27 or 3 times 9, right? So this is a 6. So these have a difference of 6, so I'm going to use 9 and 6 and 3. Right, now I look at the sign. So it has to be a negative number, right? So the only way to get a negative 6 with 9 and 3 is to make 9 negative and 3 positive. So I've factored it. Set each section equal to 0. And solve for x. So that one's solved. Add 9, x equals 9. Minus 3, x equals negative 3. There's our answers. So in this next one, first we look for a GCF, right? Can't be a number. 15 has no x, so that means there's no x GCF. That means there are no GCFs here. So if there are no GCF, I'm going to go to this part of it. So we're going to split it into 2. So if I take x to the 4 and split it into 2, I'll have x squared and x squared. Then I look at 15. 15 is 1 and 15, or 3 and 5. Right? Since I'm trying to make an 8, I'm going to use the 3 and the 5. It has to be a negative 8, so that means they're both going to be negatives. Right. Then I set them equal to 0. Actually, when you're here, so I'm going to mention this If you have x squares left in your two parentheses, what you need to do is check the numbers. Are they perfect squares? These ones are not. So we're going to go to the equals 0 step. If they are, so if you have something like x squared minus 4, x squared minus 4 is x plus 2, x minus 2. Right, so if this is a perfect square, the square root of 4 is 2, so you can split it into 2 and 2, negative 2 and positive 2. Right, but neither of ours, 3 is not a perfect square, 5 is not a perfect square, so we set both equal to 0, and we solve for x, so add 3, x squared equals 3. The opposite of an exponent is a square root. So I want to start over. So square root of 3. Square root of 3 is always positive or negative. So you got to put plus or minus in front of your square roots all the time. On the other side, we end up with x equals positive or negative square root of 5. Those are our two answers there. We actually have 4 answers. Square root of 3, negative square root of 3, square root of 5, and negative square root of 5. For this example, we've got x to the 4 minus 3x squared minus 4, right? No x on the end, so the GCF's not an x. There's no number in the front, so your GCF can't be a number. So this one is also no GCF. So we're going to jump into splitting it into 2 sets, parentheses. X to the 4 will be x squared, 4 is either 1 and 3 or 2 and 2. Right. The only way to use those, or sorry, not 1 and 3, 1 and 4. The only way to get a 3 using those numbers is the 1 and the 4. Right? And to get a negative 3, it'd have to be a positive 1 and a negative 4. When I have x squares, I check this is a perfect square. So this one's going to break down more. So this one stays the same. This one will be x minus 2, x plus 2. Right? Because 4 is a perfect square. So now I'm going to set them equal to 0. Right. My first one, I minus 1. X squared equals the square root of negative 1. Or sorry, square root of 1, negative 1. And then x will be positive or negative square root of negative 1. So one answer there. For the middle one, we add 2 to both sides, giving us x equals 2. The last one, we minus 2 on both sides, giving us negative 2 as our answer. Right. In our next example, check for GCF. Whenever you have a negative in the front, your GCF, you have to pull a negative out. Right? If there's a negative in the front, put a negative in the GCF. Okay? I also noticed all of them have x's, and x squared is the smallest amount of x's, so my GCF will be negative x squared. That gives me x, 4 take away 2 is 2. Right, the negative went with the GCF. So the middle one becomes positive because we took out a negative GCF. 3 minus 2 is 1, which we don't write. And the last one, because I took out the negative, the positive turns into a negative. 2, I took all the x's away, so just minus 2 on the end. Now we're going to split it. X squared is x and x. 2, my only option is 1 times 2. Right? For the signs, I want to get a plus 1. So to get a plus 1, I'm going to make it positive 2 and negative 1. Set everything equal to 0. Right. We got x equals 0, x equals 1, and x equals negative 2. All right. In this example, so check for GCF. I've got the negative in the front, so I know my GCF needs to be a negative. 2, 4, and 16 all have a 2 in common, so I'll pull out a 2. They also all have at least one x in them, so negative 2x is my GCF. Right. So for the first term, I'm just left with x squared. The second term will be positive 2x, and the last one will be negative 8. Right. Split this into 2. X squared is xx. For 8, I've got 1 and 8 or 2 and 4. Right, my middle term is a positive 2, so I'm going to use 2 and 4. Right, because it's a positive 2, I know it's plus 4 and minus 2. That's the only way to combine 2 and 4 to get a positive 2. Set everything equal to 0. And solve. So x equals 0, x equals negative 4, and x equals 2. Right. All right, this is the last example. So check for GCF. 3, 18, and 27 all share 3. And my lowest amount of x's is x cubed. So that's my GCF. Got x squared left minus 6x plus 9. I'm going to split it in 2, x and x. 9, my options are 1 and 9 or 3 and 3. To get a 6, I'm going to do minus 3 and minus 3. Right. Set it equal to 0. X equals 0. X equals 3. And x equals 3 again. When you get a double answer like that, the final answer would just be 0 and 3. You don't have to write it 2 times if you get a double answer. You just put it in the 1 time. That will be fine. All right, so that's factoring to solve. So we are going to be working on this today and tomorrow. So you got 2 days to practice this. If you have questions, you can reach me on Remind, and we can make a Google Meet appointment. If you